All right, so let's kind of go back since we experienced the behavior of operator. Let's go back to this example from and examine it from the very beginning. So there's certain function named f, and it's just a placeholder for some code. Obviously, there's include for string and for vector. Right, and so we create this whole bunch of fruits. I'm going to fast forward all these pushbacks to the last one here. Right, so it gets populated arbitrarily with all these strings, because this is fruit is a vector of strings. We realize how simple it is to create a copy. If we wanted to create a copy constructor does this, right, for us. Vector has a copy constructor, of course it does all this. Then we were able to sort it and everything, right? So fast forwarding that as well, so now it's all sorted. So the next thing is an example of find, and this time what I'm doing is that in this demo I'm just saying, okay, go ahead, examine this fruit 2 from the beginning to the ending, and then look for peach, which is present there, right? And of course find algorithm returns back an iterator, and so here it is, right, this little iterator line. This is a real object. This is this little helper object that is displaying itself by saying, okay, it's me, and I'm designed in such a way that now find has a copy of me, and I'm actually, I am connected to this container, and my position in this container is here. So it sort of like does all this to visualize itself. So on the next line here, we call our iterator here P1. So now to kind of formalize it and give it a name, we display it in this demo as P1. It's our little object, helper object, which is helpful because it knows which container and what particular position in that container it has, right? So another similar case, create another iterator which basically says find, and if you see, if I animate this again, if I click once again, you see there's a little dance that happens around here with those lines during the animation. It's because find really creates an iterator and starts iterating and comparing the values with watermelon and eventually finds it. Right? So there's some dance that takes place. It's really some work that is done before it actually says, okay, so here it is, right? So it's a true process here. So then find is out of the way. We create P2. So we created P1 and P2, two iterators for some reason, and we're pointing to these two elements in our fruit2 vector. Right? So now here's a list operation example. First example, erase. Basically what it says, erase says, you give me two positions. Give me two positions. And the elements will be erased between those two positions. But if you recall our discussion about half-open range, it means that all ranges, when the ranges are used, like in this erase from P1 to P2, between those two iterators, a half-open range suggests that the beginning is included, the ending is excluded. So I'm expecting this erase to get rid of peach and pear, but then watermelon should be in place, intact. So let's say erase, right? So it does something to move watermelon to this position, but the two elements are gone, right? So originally they were there, now they're gone. Now notice this, P2, we had P1 and P2, they never changed. They specified from here to here, but themselves, they were not advanced in any way. The container, the content of the container has changed. So by a chance, P1 may still be valid in terms of its position. P2 is very dangerous to use. It would be very dangerous to say dereference it and see what you can give us back. This will crash the program. Just like pointer, an iterator could have a very bad value. So especially after operations that mutate the content of your container, you need to basically take care of your iterator positions. It's safe programming. So let's see what we do. Well, look, here's another, say that, okay, P2 does exist here, but it's not in good shape anymore. It still knows what the container is, but it has no clue that container actually changed its content and all memory has changed. And it's still thinking that here there was something that was there before, but is no longer there. So another find basically points this P2 to perhaps an existing element, right? So then P2 now is basically taken care of. So erase can also erase a single element essentially pointed by the iterator. So we say erase, it's gone. So now essentially simply by a chance at the end of this operation, erase, P1 and P2 are pointing to the ending of our container. But again, in many cases, if there are multiple elements were removed, or even the whole container could become empty. Anytime the content of your container changes, you should worry about the positions of your iterators. Okay. So we'll say, oh, wait a minute, that's unacceptable. So we'll say P1 begin, so we point it to the beginning, and then it says, say, erase P1. Again, erase one element, right? So now what happens is that everything else needs to be shifted up first, right? So internally, that's what vector does. And then it says, okay, now this thing can go. So everything was copied. This is an expensive operation, right? An expensive function. It was before any physical memory change was taking place. All this data was copied upwards to shift for, for the element which is about to be gone from the container. So important. But for us, look at the code. It's all very simple, but all these things are happening. So again, P2 in bad shape, but that's something to expect when we erase things. So then here's another example. You don't have to use just well-known positions. If I say fruit2 begin, just like with pointers, you can say, point to this place plus 5 elements forward. If you know what you're doing, the pointer will be positioned at the right address. So similarly, you can say P1 equals begin plus 1. Now look what happens. Again, watch this animation. Watch what happens. You should be able to see that first it starts the beginning, because beginning says here is the beginning, and only then the P1 basically makes its own adjustment to go to +1 position. And so again, if I click here, the animation will kick in again. So this, see how it actually goes to the beginning and then adjusts itself. So it all is happening, at runtime. But it's very useful to be able to basically say, okay, from the beginning that far, and that works. So +1 is this. Okay, what else? Insert. Insert is another list operation. Remember our discussion of lists, getting rid of elements, adding new elements. So insert. Insert, of course, wants you to specify where. So we have this P1 position here. So insert will insert the new element cherry right here, right? So what it does, it kind of like did some copying around, provided space for the new element, and placed cherry here. So insertion, insert works very similar to how when we type, right? If I want to insert here and say something else, something like this, the whole portion is pushed forward, right? When my insertion point here, right? Then if I want to insert something, this whole portion will be pushed forward. That's exactly what happens here with this insert, right? So that when you have this position and you say insert, everything from this position and forward will be pushed and then of course we're going to have space now there, and that's where the new element will be placed. So insert clearly is a list operation, and as you can see, the object is doing some work. You know, it's rearranging elements. There is no joke about it. It's not like it's instant or anything. There is some work that vector has to do to be able to do this insert. So here's another example. P2 now points to the ending -2, right? So the ending is non-existent position. Cannot dereference that. Cannot find out what is stored there. It's illegal to find out, but it's a legal position in terms of positioning. Then we say and -1, -2. So now we're pointing to this, and we can insert another, like something that says cranberry there, so it gets inserted. So these are examples of list operations, right? So removal of elements, addition of elements at a specified position is considered to be list operations. Okay. Whereas remember where we started, push, pop, those were like stack-like operations. These are list-like operations defined on vector.